to class. This is Wednesday, May 6th, and yesterday, or actually Monday night, you were given the test, and we're getting to the final. This is the last step. The last teaching we have to do is over the next 3 days. So we're going to do this in 3 parts, which will be Wednesday, Thursday, and then the next Monday. And then you'll have about 8 days to do the final. I don't think you'll need all of that. So we're going to finish with plenty of time. And so here we start. The first problem is find g composite f of x, which you remember is a function of a function. So if f of x is x squared minus 5, that's the inner function, and g of x is equal to 2x plus 3. So g composite f of x is written as g of f of x. Now f of x is arrowed down because f of x is x squared minus 5, so g of f of x is g of x squared minus 5. Now notice how I arrowed the x and g of x to be 2 times, remember we said whatever was in the parentheses plus 3. So that's what we're going to do now. 2 times whatever's in the parentheses plus 3. And whatever's in the parentheses is the x squared minus 5. So 2x squared minus 10 is what's that part, and then plus 3 gives us 2x squared minus 7 for our answer. Now this is a little bit longer one. Some of these you'll see are easy and quick, like 3 and 4. Some take longer and are kind of, several steps. This is one of those. So find f inverse if f of x is 3x over x plus 1. So I'm trying to lay out some steps here. First, replace f of inverse of x with y, so we have a y and an x, because on step 2 we have to interchange the x and the y. So it was 3x over x plus 1, now it's 3y over y plus 1. The x's have become y's and the y's become an x. Now the next thing we want to do is to multiply by y plus 1 on both sides on step 3 here. So now we have x, y plus 1 equals 3y. And of course then we next multiply through the parentheses. Xy plus x equals 3y. Then we would subtract the x, leaving us with xy equals 3y minus x. Then we would subtract 3y from both sides so we can get the 2 y terms on the same side. So now we have xy minus 3y is equal to negative x. Now the y's on the same side, we had to do that so we could factor out the common factor y. And so now we have y parentheses x minus 3 then equals minus x. Now finally we can divide both sides by x minus 3 and end up with y, or f inverse, equals negative x over x minus 3. So that was a long one, but just see the steps and see how you have, whenever you have a fraction, you have to multiply through and end up with a fraction. Now see, this is the easy ones I was talking about. This is y equals log base 9 of 27. And remember, if it's not a base 10 or a base e, I can do it by the change of base function. So I can take log of 27 divided by log of the base, comes out 1.5, but we want fractions, so 3/2, and that's all I need. Now the same thing for 4. Log base 9 of 28 is log 28 over log 9, and this works for any base. So that's equal to 3 places to 1.517. Now here we have some longer steps, but this isn't too bad here. So it's to write as a single log. In other words, we're going to combine them all back together as one log. So we do this in steps. First what we're dealing with is 2 ln x minus 4 minus ln x squared minus 16 plus ln x squared plus 5x plus 4. So one of the first things we'll do is bring the 2 in front of ln x minus 4 up as ln x minus 4 squared. That's the exponent rule. And then remember on the line below that now, whenever we have a subtract, that goes on the bottom fraction, the denominator, and a plus goes on the top. So now we have ln x minus 4 squared minus ln x minus 4, which is going to go on the bottom because of the minus, plus ln x plus 4 x plus 1, which will go on the top. So now the plus is going to allow me to multiply. So this is getting us to 1 log now. ln of x minus 4 squared times x plus 4 x plus 1 from the third part. And then the minus part goes underneath x minus 4 x plus 4. Now we can see in the single log that an x plus 4 cancels and an x minus 4 cancels, leaving us with ln x minus 4 x plus 1. Now on this one, we're going to use the log to take the log of both sides, which remember takes the exponents down to the regular level where we can get at them. So 3 to the x plus 4 power equals 9 to the x. We log both sides. That brings x plus 4 in front of log 3 and x in front of log 9. Now we have to multiply through the parentheses on the left, so x log 3 plus 4 log 3 equals x log 9, and we subtract x log 3 so we can get all the x's over on one side. It's a little easier this way. So 4 log 3 is equal to x. Now here's where I factor out the x because it's on two places there. X parentheses log base 9 minus log base 3. And so then to get an answer, we can finally divide by log base 9 minus log base 3. And here's what we'd have to do. So 4 log base 3, enter, and then you enter, well, when you come to do the divide, it'll bring up a and s divide, and then you have to do parentheses log, and then the 9 needs its own parentheses, minus log 3, and 3 needs its own parentheses, and then a final parentheses. And if you do it right, it'll come out to 4. If you don't have enough parentheses, or don't put the closing parentheses on the 9 and 3, you'll get 2 something. So you have to do it just this way. Now this is a pretty quick and easy one. We start out with ln x minus 3 equals 8. And we always try to get the ln by itself, so we divide both sides by 6. And we get 8 over 6, which simplifies to 4 over 3. Now, the way to clear out the ln is to take its inverse. Remember we talked about the doppelganger and the two things that cancel each other out, like matter and antimatter from Star Trek? Well, if I take e to the ln x minus 3, I lose the ln, and I just come out with x minus 3, but equals e to the 4 over 3. So now I'm going to get an answer by saying e to the 4 over 3 plus 3 comes out to 6.79 to 2 places. Now here we're asked to graph several equations, but we're only going to ask you to use 3 points. So y equals 2x is a doubler. Remember we did the penny doubler that Charity likes so much? We got up to a few $1,000,000 by the end of the month. So here, if we have -1 for an x, 2 to the -1 is 1 over 2 to the 1, so it's reciprocal. -1 is reciprocal. So when x is -1, y is a half, 2 to the 0 for x0 gives us 1, and 2 to the 1 gives us 2. So those 3 points are shown there, and that's the upward going exponential because it's got a positive x. Now for b, we have a negative x, which means it's a downward going exponential, but we can take the 2 to the -1 out, remembering that it is the reciprocal that makes us take, so that gives us 1/2 to the x, and shows us that we're going to be decreasing because we keep multiplying by half. So when x is 1, 1/2 to the 1 is 1/2. When x is 0, anything to the 0 is 1. And when x is -1, remember that reciprocals that and gives us 2. Okay, so you kind of work backwards on this one. 1 gives us 1/2 high, 0 gives us 1 high, and -1 gives us 2 high, but you can see as we draw the arrows through, it's falling to the right. Now here we're going to do logs, and logs are the inverse of the exponential. So here we're going to do log base 2 of x, And we can do this on the calculator as log of x divided by log of 2. Remember our change of base. So log of 0.5 divided by log of 2 gives us -1. Log of 1 divided by log of 2 gives us 0. And log of 2 divided by log of 2 is of course the same and gives us 1. So as we look here, we see that when x is 1/2, y is down 1. When x is 1, y is 0. And when x is 2, y is 1. Now here, we're going to take the log to the 1/2 x, and again, we'll use the change of base. So log to the x divided by log to the 0.5. For x equals 1/2, we get 1. For x equals 1, we get 0. For x equals 2, we get -1. And there we have that over there. Okay, now here we have a population decrease from 71,300 in 2010 to 69,885 in 2014. So it's decreased in 4 years. So determine the annual percentage decrease and predict the population in 2030. Well, we start out with the end result is the 69,885 in 2014 equals the starting result, 71,300, equals 1 plus r, the r is the interest rate in decimal, to the 4th power. We're multiplying the 71,300 by the 1 plus r each time for 4 times. So now what we need to do is divide out the 71,300, and I don't want to do it yet because it's a messy fraction or a bit messy decimal. So then I have 1 plus r to the 4 is that 69,000 over the 71,001. Now what I have to do is take the 1/4 power on both sides. So up there, I'm taking 1 plus r to the 4th times the 1/4 power, cancels that and gives us 1 power. So then I get 69,885 over 71,300 in parentheses to the 1/4 in parentheses. And what that gives me is now r, I still have to subtract the 1 over from the 1 plus r on the other side. So r now fully is left just like this on the calculator. Left parentheses 69,885 divide 71,300 power 1 divide 4 minus 1 equals -0.005. Or moving 2 to the right for going from decimal to percent, -0.5%. So that's a 0.5% decrease. Now wanting to know what it is in 2030 is 20 years after the 2010 initial amount, which is the 71,300. So now we know that we're declining by 0.5%. So we just put it in as 1 minus 0.005 power 20 is shown, and that gives us 64,499 to the nearest whole number. Okay, now by what percent with the annual return from an investment at 5% compounded continuously? Now compounded continuously has the formula, the amount is equal to the principal e to the RT, interest rate times time. Okay, we want to compare that with the same investment compounded quarterly. So that formula is A, P times parentheses 1 plus R over 4 to the 4 times T, 4 times a year in other words. So now we plug in to the continuously. A is equal to, we don't know A or P, but that's okay, we can still compare them. A equals P e to the 0.05 times 1 year. So we get for that out to 6 places. A equals P times e to the 0.05 is 1.051271. We need that kind of accuracy. Now for the quarterly, it's A equals P, parentheses, 1 plus 0.05, the annual divided by 4, because it's 3 months, and then power 4 times 1, or 4 times that 1 year. So when I do the same, I get A equals P, 1.050945. That's the 1 plus 0.05 divided by 4 power 4 in parentheses. So now I can subtract the amounts of P from the continuous 1.051271P minus 1.050945P, And I get this thing on the calculator that looks a little weird, but it's 3.26 e minus 4, which just means takes the decimal and shifts it left 4 places, as I'm showing here to the right. So that gives me 4 shifts to the left, 0.30326, and 0.30326 to become fraction gets shifted right twice, so that makes it 0.03%. Okay, now this is a little bit of a long one too. So 11 is x plus 6 over x squared minus 4 plus 1 over x squared plus 5x plus 6 minus x over x squared plus x minus 6. Now we have to find the LCD from this, so in order to do that we have to factor. So we have x plus 6 over x minus 2, x plus 2, difference of squares, plus 1 over x plus 3, x plus 2, that gives me the 5x plus 6, and x plus 3, x minus 2 to give me the plus x minus 6. Now looking at all our common denominators, we have x plus 2 in the first and the second one, so it's got to be there. We've got x plus 3 in the second and third one, it's got to be there, and the x minus 2 in the first and third. So those are the 3 terms that I need. So what this means now is that I have to multiply the top, where all the focus really is, by the part that I don't have in the original. So for the first term, x plus 6, I have x minus 2 and x plus 2, but I'm lacking x plus 3. So I multiply by x plus 3 over x plus 3. Now on the second one, I have x plus 3, x plus 2, but I don't have x minus 2, so I multiply by x minus 2 over x minus 2. Notice all I'm doing is getting stuff for the top to work out. And then on the last one, I have x plus 3, x minus 2, so I'm missing x plus 2, so times x plus 2 over x plus 2. Now multiplying the top out, we've got, just looking at the top, because we could put the bottom back on when we're done. X plus 6 times x plus 3 gives us x squared plus 3x plus 6x, or plus 9x plus 18. Then the second one has a top of just x minus 2, and the third one has a top of minus x squared minus 2x. Now I'm going to collect my terms, so I have x squared minus x squared, so those cancel. I have 9x plus x minus 2x, that gives me 8x, and then I have 18 minus 2 is 16. So I have 8x plus 16 on top, which I can factor out to 8 parentheses x plus 2, and then putting back the bottom, the x plus 2's cancel now, so we're left with x over x minus 2, x plus 3. Now on 13, we're going to cross multiply, and so that would give us 4 times x squared minus 2x plus 1 in parentheses equals 3x plus 9 times x minus 1. Now the left one is pretty easy, just multiply everything by 4. 4x squared minus 8x plus 4, and now on the right, we're going to do 3x squared, the first, minus 3x plus 9x gives us plus 6x for the outer and inner, then minus 9 for the last. Now we're going to move everything over to the left, so we're going to subtract 3x, subtract 6x, and add 9 over to the left, and that's going to give us 4 minus 3x squared, x squared, negative 8 minus 6, negative 14x, and plus 4 plus 9, 13. So now this factors out as x minus 13, x minus 1, and the answers then would be x equals 1 and x equals 13, except when I look at the right side over there, originally I have 4 over x minus 1, and if I try to plug in the 1 there, I get 4 over 1 minus 1, which is 4 over 0, which is illegal. So that leaves only x equals 13 as my answer. Now here we go, it says, write a function expressing the translation of 1 over x. Well, let's remind ourselves of what 1 over x is just something that it just looks like what we have right here that I'm pointing at. Okay, now, what we have on the curve is, if you look at what would be printed on the page, is the center line for the y is over 4, which means it's 4 to the right, and the x center line is up 2, so that means it's up 2. So we can write that simply as 1 over x minus 4 in parentheses or you don't really need the parentheses, plus 2 like that, and that's all we need. Now in 14, match each characteristic of a rational function f of x equals p of x over q of x, p being the numerator and qx being the denominator. So if the degree of px is equal to the degree of qx, then the asymptote could be something like y equals kx squared over x squared, where the highest power terms on the top and bottom cancel out, leaving just k. Now for b, the degree of p is less than the degree of q. That could give us something like, y equals kx over x squared, where the x squared on bottom is bigger than the x, which drives it to 0. So the horizontal asymptote would be 0 there. Now for c, the zeros of q of x are matched by corresponding zeros of p of x, and this is called the point discontinuity. So this is where you have something like both factors canceling each other on top and bottom. So if you have something left on top, it'll just be that, but you'll have point holes where the points are for like x negative 2 and x equals 1. Now for d, it says the 0 of q of x is not matched by a corresponding 0 of p of x. This means there is a vertical asymptote, or have an unmatched something on the bottom. So like if it was x minus 1 over x plus 2x minus 1, the x minus 1s would cancel, and you'd be left with the horizontal line, which becomes an asymptote of x equals negative 2. Now on 15, on a trip, the Jones family averaged 45 miles on the way up and 60 miles on the way back. They traveled the same distance both ways. What was the average speed of the trip? Well, average speed is total distance over total time. So the total distance is there and back again, or like the Hobbit book, 2d, d up and d back. Now, in order to see what we need is we need time. So we've worked this equation over. The speed is equal to the distance divided by time, to say d is equal to d over speed is equal to time. So the d, which is unknown, over the speed is what we'll use for the 2 times. So d over 45 is the time for the 45 miles up, and d over 60 is the time for the 45 miles back. Now notice the prime factoring of 45 is 5 times 9, and the prime factoring of 60 is 5 times 12. So our common denominator is 5 times 9 times 4, and that gives us 180. So we multiply top and bottom by 180. That gives us on top 360d, and 180 over 45 is 4d, and 180 over 60 is 3d. So we end up with 360 over 7, or 51.4 miles on the average for the total trip. Okay, so we're going to omit 16, and then 17 is a snap. Cotangent of 78 is 1 over tangent 78, which should come out to 0.2126. Make sure your mode is radians. Now for a right triangle with side 12 opposite the angle 40, we can, and A equal to 40, we can get B, because we know it's 90 minus 40, or 50. And then we can say tangent 40 is 12 over B. B times tangent 40 equals 12. Divide both sides by tangent 40, and B equals 12 over tangent 40, or 14.3. Now sine equals 12 over C, and multiplying through, C times sine 40 equals 12, and 12 over sine 40 is 8.7, so we're finished with that. Now on 19, state the 3 trig ratios of an angle in standard position if its terminal side passes through negative 2, 6. So we look at the origin, we go left 2, up 6, so that becomes our x and y. So we know that the radius, or the distance for the hypotenuse is square root of negative 2 squared plus 6 squared is equal to square root of 4 plus 36, or square root of 40, which for perfect squares is the square root of 4 times the square root of 10, or 2 square roots of 10. So now we can do our sine is of theta is y over r, which is 6 over 2 square roots of 10, which becomes 3 square root of 10 over 10 to clear out the square root of 10. And cosine becomes x over r, or negative 2 over 2 square roots of 10, times square root of 10 over 10 to clear out the bottom, becomes negative square root of 10 over 10. And lastly, tangent is equal to y over x, or an easy 6 over negative 2, or negative 3. So 2 more days, and we're done with this. God bless you.